Surely, this next winter can't be any worse, especially for the mountains. Surely, we're going to have at least one cold snap this year. We'll find out when the winter comes around. This is my way too early predictions that probably shouldn't be made, but I have too much fun doing this, so I'm still going to be making them anyways for the 2026 to 27 winter for the Willamette Valley. I'm meteorologist Hannes Leach, and let's go through the annual disclaimer slide. This is a long-range forecast intended to provide a general sense of what may happen in the coming months. It is not that this is for sure happening, nor is an excuse for you not to be prepared for any extreme weather events. Also, because this is an 8 to 11 month outlook, this accuracy will be even further reduced compared to the usual 55% industry average that normal long range predictions have. I do this because I have fun doing it, not because it is the most accurate. All right, let's go into our methodology. As I've grown better at these ultra long range forecasts, I am incorporating more and more of my October methodology into it, though I refuse to use top analog years. So now via the relative Nino index, that is a change that the National Weather Service and NOAA has put out for the official designations for El Nino and La Nina, where instead of just doing the raw sea surface temperature anomalies, they compare it to the global sea surface temperature anomaly, and then the region minus the global anomaly is what it comes out to be for the R, O, and I. Because again, this is an 8 to 11 month prediction, I'm using a heavy reliance on subsurface temperatures versus the actual forecasts. I will confirm it using the Southern Oscillation Index as well. I will also use the Pacific Decadal Oscillation, the Quasi-Biannual Index due to how predictable it is, and then sunspot count. I will use statistical analysis for the analog years, though the analog years themselves will not be weighted any differently. They will all in general have an equal weighting for the April forecast. And then all forecasts will cover what has happened in 1 out of every 3 winters at the Portland airport. In terms of adjustments I've made to past data, snow before the 1970s, I am adjusted to a 4.3-inch average per winter on analogs. Further adjustments are made if necessary for marginal setups. Temperature departures are adjusted to the averages at the time that they occurred. So if I'm using like 1924 to 25, for example, as an analog year, I will be using the averages that were in use at the time, which was 1891 to 1920. Since downtown Portland was used for analogs before 1940, I converted the precipitation over to a PDX equivalent, which is 83.8% of what downtown gets for Eugene, because Eugene's official site's been the same since 1892. I don't need to make any adjustments for that. So onto our data and oscillations. And with the change to the R, O, and I, not every model has adjusted to that yet, so I'm only going to show the CFS for the US's look. It's showing a moderate El Nino for next fall, though there is significant uncertainty with its ensemble members going from a super El Nino, they're not record high, down to a weak La Nina. I think it'll probably not be in the weak La Nina range. Just gonna put that out there. But again, predictions this far out are highly uncertain. Normally, we don't have a clear look of what ENSO is going to be in terms of the exact magnitude until about August or September. Subsurface anomalies, there is a significant amount of above normal temperatures between about 100 and 200 meters below the surface, and this has been growing over the last couple of weeks, especially as the last little bit of colder than normal anomalies have grown smaller. It's smaller, so that does give me extra confidence that we'll get a El Nino of some sort. Strength is a little bit to be determined. Australia's outlook is pretty confident we're getting a strong El Nino by the time we hit late summer, and going into a super El Nino by the fall. And they have it as a 100% certainty of El Nino by June. In terms of the windstorm factor, the further you go into El Nino or La Nina, the less likely it is to get a major windstorm. You want to be either in that weak El Nino or La Nina or in the ENSO neutral range if you want a big windstorm. Now, look at the Southern Oscillation Index over the last 2.5 years. It is still positive right now. Now, that normally favors more La Nina-like conditions overall, so that might dampen the formation of El Nino at least early on. But again, because this is April, it's too early to firmly say it's going to dampen it, especially because it's not that far in the positive compared if it was like 20 to 25 as it has been previously in its history. So going on to the PDO, it is also no longer safely negative. We're only at about a -1 anomaly right now, which is the highest it's been since early 2021. So we'll see if it stays negative as we go closer to October. I'm still going to forecast this as if it is negative just because it has been predominantly negative. Also, the thing to know, I've included this trend line and since I've started doing these long range forecasts on YouTube, and this is the flattest I have ever seen it. And I'm not going to be surprised if this looks like it's going to go positive, if not the end of this year, probably next year, because El Nino conditions tend to make the PDO lean a little bit more positive than other years, though that's not always the case, as 2023 to 2024 showed. So taking a look at the QBO, we are currently in the easterly phase from about the 20 millibar level and higher. Does look to be flipping to the westerly phase by the... Okay, that was said wrong. For the QBO, we are still in the easterly phase officially, but it is flipping to westerly actively. Above 20 millibars, it is a westerly wind flow, though it is still primarily easterly between the 30 and 70 millibar level. It'll probably be complete westerly by the summertime, and generally when it flips westerly by the summertime, that's a pretty good indication it'll stay westerly during the winter months. Sunspot count, we are past the solar maximum. We're about 70% through overall and about a third below the peak. So that does still tilt things towards El Nino, but it is not a firm El Nino is going to happen. Sunspot's the weakest correlation of everything that I use, so it gets generally put on the back burner overall and is generally used in tiebreaker situations for top analogs, which granted I'm not even using, so I'm just including it for reference. In terms of our analog gears, this is going to be my starter analog gear set. I'm using 30 for my starter analog gears. A couple of these happen to be carryovers from last year. And what I mean by that is, for context, I start every year with a blank slate in terms of analog years. A carryover is when a top analog from last year is also in this year's analog year set. And going from most recent to furthest in the past, 2018-19, 2014-15, and 1968 to 69 are the modern carryover years, at least the ones that I was consistent about for the top analogs. So what happened in these analog years? Well, let's find out. First off, with water year rainfall at PDX, the overall median was 33.46 inches. Although it's not shown here, I did take a look at what happened in the year prior and what happened in these analog years. If I look at the downtown data before 1940, there wasn't really a correlation. Since 1940, when we flipped over to PDX data, there was a pretty strong correlation that the year, or this El Nino year, was more wet than the La Nina / ENSO neutral year that preceded it. Most of these analog years are El Ninos or warm ENSO-neutral years that followed either a La Nina or a cold ENSO-neutral year, just for context. So that gives me a pretty good indication that using this median is not the best idea at face value, especially when the trend cast currently at PDX is 40 inches. In Eugene, 39.5 inches was the overall median. I will note there was a pretty significant cluster right around the 40-inch mark, which is just slightly below their average of 40.7 inches. And again, for context, the water year runs from October 1st through September 30th. Temperature departure from normal at PDX, the overall median was about a degree above average. There was a big cluster in the older analogs right around 2 degrees above normal. There were a couple years that were significantly above average and one that made it to significantly below average. So it's still possible to get everything. We'll see what my top analog show come October, assuming this even holds. Temperature departure from average in Eugene, a little bit cooler, about 7/10 of a degree above average. And no strong clusters in terms of the all analog years. Lowest temperature at PDX, 21 degrees is what it came out to, and no real strong clustering. In Eugene, there was a strong cluster right around the 25 to 27 degree mark. The overall median was 19 degrees. I will note that the coldest temperature Eugene has ever experienced, -12 in December of 1972, that is in the analog year set. So it is possible to get extreme cold even in an El Nino. 1972 to 73 was a super El Nino on top of that. Adjusted snowfall at PDX, that's a lot of zeros on the graph here. But one thing I will note is that this is not QBO adjusted, and QBO data did not become reliable till right about where my cursor is right now, the late 1950s. So since then, I have better data on the QBO. Before then, I rely on everything else. The median is about 1.5 inches after adjustments, and there was only 2 years that got into the hyperactive category, which is 12 inches or more. In Eugene, the median was even lower, 0.15 inches. The Eugene's snowiest winter on record, 1968 to 69, is in the analog year, your data set. Also, as a side note, this dot here for 2018 and 19, I don't know why it's so low. Eugene had about 19.5 inches, so that dot should be up here. So just side note, that is a chart error. And moving on to our historically significant trends slash statistics here. All above median snowfall years that occurred with an El Nino did happen with the westerly QBO at the 30 millibar level on January 1st. As a disclaimer, this is not a guarantee that snowfall will happen if these two patterns line up. Multiple El Ninos have had below median snowfall with westerly QBO. I think there was only one that had snowfall, and the other ones had no snowfall when it was a westerly QBO. Hit rate was about 77%, so that's pretty good, in my opinion. The last snowless El Nino with a westerly QBO was 1982 to 83 using this specific criteria. There's also been no deep Arctic blast, which I define as -12 degrees Celsius at the 850 millibar level slash 4 to 5,000 feet over Salem. For 12 winters, this is now a record high. If I'm pure guessing, the chance of a 13th occurring is 4%, which on face value seems like pretty good odds. Odds that one would occur. However, El Nino does produce these odds. This is one of the stronger correlations I have noticed. That deep blasts have only occurred in December with a moderate or stronger El Nino. Shallower blasts have occurred in January and February with a moderate or stronger, but generally speaking, it was is either ice storms and you just got super cold at the surface and Mount Hood was 40 degrees, or Portland was in snow and the rest of the valley was in rains. Situations like that. Also, as a known case, anyone's wondering what's easterly QBO, it was a pretty strong correlation with no snow. And there was a few that had snow, but it was all like an inch. For westerly QBO seasons, that's what you want if you want a 10-inch plus snowfall year at PDX. All but one 10-inch plus snowfall years happened with the westerly QBO at the 30 millibar level on January 1st since QBO data became reliable. So with that all being said, let's move on to the prediction. Yeah, this is actually the first year since I've started posting these on YouTube. I have not used the 20-degree statistic. It's because it's not necessary this year for once. Start with the basics. Rain, because of that correlation between last year and the analog years that are in my starter set, I'm tilting it above normal, 37 to 47 inches. I'm going above the recommended median because of said correlation, especially because that's a modern correlation. Temperature departure, it does favor above normal, but at first glance does not favor extreme. I'd say 0 to 2.5 degrees above average. If you told me make a best estimate, I'm going to pick 2 degrees just because of that cluster. Windstorms, tame, less than 49 miles per hour is what I'm going to predict. Lowest temperature, it is a little too conflicting to call in terms of the tiers that I have for that, especially because everything does seem to be possible still. And then most likely be active. I refuse to make this prediction in April, even if I am extremely confident, because I do require top analog gears. Snowfall department, for mountain snow up on April 1st, I do anticipate it'll be good compared to this year. While I didn't show mountain snowfall graphs, there was a good recovery on most of these analog years. The one exception is 2014-15, which was one of the worst snowfall years on record. So let's hope that does not get in the top analog years if you are a skier or boarder or even care about the water supply. So 80 to 120% of normal is going to be my starter prediction. That is based off of it being a little bit warmer than average, but a little bit wetter than average. Valley snowfall, I'm just going to take the raw valley and just say 77% chance of median or higher. If you told me, put into one of your tiers, please. 2 to 8 inches is what I would go with at PDX, or 4 to 12 inches at Eugene. Eugene, I'm going to lean aggressive as a result. But again, that's if I was forced to make one prediction with this data, and I'm more confident about that PDX prediction than Eugene. Chance of a no snow winter, 20% approximately. And that is going to be it for this video. So thank you all for watching. I know next winter is still at the earliest 7.5 months away. So we have a lot of time. And until my October forecast comes out, stay safe out there and take care.